In our real life, we see the houses, bridges, the trains, and the airplane. And in these, there is a common thing between all these structures. You will find that there is a beam extending where one end is fixed and other end is free. So here you can see clearly in this plane, this end is fixed and this end is free. So these kind of beams are called cantilever. And in today's session, we will learn how to perform the deflection of the cantilever beam analysis in Ansys workflow. Okay. For this analysis, the geometry of the cantilever beam that will be used is shown here, and the material we will be using is aluminum alloy, and the loads will be the gravity and the force of 500 Newton at the region. Okay. So in this tutorial, we will learn how to import the geometry in Ansys space claim, the access material from Ansys library and apply to a body, apply fixed support and apply force. Okay. So now let's go to the workbench, and first we will take a static structural module here. Then you go to engineering data, right click, edit. Now here you can go to engineering data sources. So this is the Ansys material library from where you can get the different material available in Ansys library. So here you can go in the engineering data source, general material, okay, and outline of, you can go to the outline of the general material, and here you can search for aluminum alloy. Okay. Yeah. So this is the aluminum alloy. Now you can click on the plus sign here to add this material into your engineering data. Okay. Now you can cut it and then again open engineering data, and here you can see aluminum alloy is inside the engineering data. Now to import the geometry, we can first open the space claim, or we can also import directly geometry from here. So in presentation, I have shown you the way how you can import from the space claim. For now, I will directly import the geometry from here. So then you can go to the location of the geometry and geometry select. So once the tick mark is done, the geometry is selected. Now open the model. Once the model is open, go to select the geometry and then go to assignment and double click. Here the list of the material available in the data will be shown. From here you can select the material. So now the material is changed for this model. To verify this, we can go to geometry and then go to display type as material, and here you can see aluminum alloy is applied to this part. Then you mesh it. We'll just go with the linear element type and the mesh size of 10. Generate mesh. Then go to static structural, right click and apply fixed support. Okay, to apply fixed support, select the face and apply. So the fixed support is applied on this. Now we want to apply force of 500 Newton on this. Again, right click, insert, and paste. And select the face on which you want to apply. Now to apply the force in Y direction. To apply the force in Y direction, change this definition by 2 vector to component and then apply the force of 500 Newton. Here you can see the direction of force. To apply the gravity, right click and Here it is the standard earth. And you can select the direction of the gravity from. So we want to apply the direction of gravity in positive y. Okay. So here you can see all three loads and boundary conditions are defined with support force the standard of gravity is applied. In the presentation that I will be sharing, gravity is not applied in that one. So you have the fixed support and the force one. Now to solve it, analysis setting and everything, keep it by default. To see the result for the deformation, we can in the solution create total deformation plot and equivalent stress plot, and then right click here in solution and then solve. Once the solution is completed, we can check the results for the plausibility. So for example, if I take the deformation and try to look for the deformation behavior of the structure, force is being applied on the y direction and the gravity is acting on the y direction, it is plausible that the free end of the beam will go down from this one. Okay, and the stresses, the stress distribution you can from here. So the maximum stress of 21 megapascal is observed at these regions, okay, near to the fixed.